All right, so that was a lot of information. So let's take a look at a quick summary. And I've generated this kind of decision tree type of thing to help you out with this. It doesn't have every single example on here, but it has quite a few. So let's just take a look at how we're going to use this to help name our compounds. So for example, let's go ahead and start off with NaCl. The first thing that we're going to ask ourselves is the metal or is the compound composed of a metal and nonmetal or two nonmetals? In this case, sodium is a metal, chlorine is a nonmetal, so we're going to go with a metal and nonmetal. So we're going to go over to the left here where it says metal plus nonmetal, and of course that's an ionic compound. The next question that we have to ask ourselves is the metal of fixed charge? So that includes group 1 and 2. And then there are, of course, some other exceptions. Aluminum is always aluminum 3+, so that's also fixed charge. Silver is always Ag+, and then zinc is always zinc 2+, right? So that also goes in there. I don't want to include it because then it gets a bit wordy. Or is it a variable charge transition metal? Well, sodium is in group 1, so it's a fixed charge. And so the way that this works is that we get the name of the cation plus the base name of the anion, and then add the "ide" ending. So for example, this would become sodium chloride, right? And you can see how you can use this decision tree along with a periodic table to help you figure out these names. Next up, let's take a look at Cr2O3. So in this case, we have chromium, which is found right there on the periodic table, and then oxygen, which is right there. If we go through our first question, is this metal plus nonmetal or two nonmetals? Well, it's a metal plus a nonmetal, so it's an ionic compound. Is the metal of fixed charge or is it a variable charge, aka is it a transition metal or a post-transition metal? And so in this case, it's a variable charge. So we're going to have this type of naming structure. And you can see I've included an example of each one. So you go with the name of the metal, the charge of the cation in Roman numerals, plus the base name of the anion with an "ide" ending. So for example, we first have to figure out the charge here. We know that oxygen always has a -2 charge. We multiply that by 3 because there's 3 of them. And then we think about what does the chromium need to cancel out all of these charges. If you think about it, the oxygens make up -6. So the chromiums have to be combined +6, which means each one has to be +3. And so what we do here is the name of the cation, the charge of the cation in Roman numerals, plus the base name of the anion. So this would be chromium 3 oxide. Note that the post-transition metals, other than aluminum, these also have variable charges, so these also follow that same naming structure. Let's take a look at another example. So here we'll do CO2. And so take a look at our handy dandy periodic table. Carbon's right there, oxygen's right there. Is the compound ionic or covalently bond? Of course, we know this one's a covalent bond. Does it start with an H and is it aqueous? So acids technically do need to be dissolved to act as acids, but we're just going to say anything that starts with H, we're going to call it an acid. So in this case, we have CO2. We have no H's, so no, this is not an acid. And here we get the prefix of the first element plus the prefix, plus then the prefix and then the name of the second element, and then we add the "ide" ending as well. Of course, if it's mono on the first element, then we ignore that mono part. So for example, here we have CO2, that's carbon. We ignore the mono because it's the first one, and then it's dioxide, right? So don't forget to add that "ide" ending. I should have "ide" there. Next up, let's take a look at HNO3. So first question, is it metal and non-metal or is it two nonmetals? It's a bunch of nonmetals. So we have a covalent bond here. Does it start with an H? Yes, it does indeed start with an H, which means that it's an acid. Does it contain a polyatomic ion with oxygen? Yes, it does indeed. So it's an oxy acid. Is the naming ate or ite? So if we think about NO3, that's nitrate. And so if we go down here to our decision tree, that's an 8. Then it goes the base name of the polyatomic ion plus an ic acid. So for example, you can see I have sulfuric acid, right? Don't forget that sulfuric and phosphoric are a little bit weird because they get the either ur or added to it. So again, base name of the polyatomic ion plus ic acid. This would then transform into nitric acid, right? From nitrate to nitric, and then add the word acid towards the end. Let's take a look at HSO3. That's my bad. H2SO3. Again, we've got covalent compounds. Yes, it does indeed start with an H. Does it have a polyatomic ion? Yes, indeed it does. Does it have an ate or an ite ending? It has the ite ending. So we need the name of the base name of the polyatomic ion plus an us and then acid. Note that, of course, in the case of the sulfate and sulfite, we add an So this would then change to sulfurous acid, very angry acid. Actually, it's not that bad of an acid. And then finally, we have one more example. We have HI. And so let's go ahead and start with the same thing again. Is it metal or non-metal, or is it ionic or covalent? It's going to be a covalent bond. Yes, indeed, it does start with an H. So it's an acid. Does it contain a polyatomic ion? No, it does not. So in this case, it's a binary acid. And for binary acid, we add the hydro plus the base name of the metal, and then ic and acid, right? There's hydrochloric acid in this example. So this would then be hydroiodic acid. So you see how all the nomenclature is very systematic, and this chart can kind of help you out with it if you like it. If you don't like it, you obviously don't have to use it. Really, the main thing that's going to help you is practice, practice, practice. So if you think about the practice, obviously you have these videos and you've been doing the work along with these. So that'll provide you a good bit of practice there. We're also going to have the homework checks to help you out with the practice. We're going to have a lab on this, so that'll be more practice. And if you still need more, I'll have a list of extra resources. But really, it's just something that you want to do until you get it.